Most of us treat AI like a high-tech magic 8-ball.
Oh, totally.
We ask a simple question, and we get a generic answer back.
Exactly. You've probably seen the viral trends, like asking an LLM to analyze your whole chat history. It's fun, yeah, but it is just the very, very tip of the iceberg for what these tools can actually do for you.
Okay, so let's unpack this. This deep dive is about the truth of advanced prompt engineering. We're moving beyond just talking to the machine.
We're learning how to build structured systems within it.
And the secret here, it isn't really about which model you use.
No, not at all. It's about how you talk to it. It's how you architect the input.
We've pulled back the curtain on the systems used by researchers at places like Google, OpenAI, and Anthropic.
And we've broken them down into 10 surprisingly simple but really powerful techniques.
This is basically your blueprint to go from being an amateur to, well, an AI architect.
And it all starts with one essential mindset shift. You have to stop thinking of the AI as a human assistant you chat with.
And start treating it like a complex simulator you direct. Here's the core truth that really changes everything. The AI does not think. Not in the way a person does. It doesn't have an opinion.
Right. It's a highly sophisticated probability engine, a simulator that has, processed basically the entire internet.
Because it's read everything, it knows how a Nobel Prize-winning physicist talks.
And it knows how a sarcastic teenager talks. It has a library of a million different masks it can wear.
The moment most users fail is when they ask for its opinion without setting the stage.
Yeah, if you don't tell it which mask to put on, it just defaults to this boring, generalized, super safe average of everything it's ever read.
That's the blandest possible result.
Okay, let me use a quick analogy to really nail this down. You wouldn't walk into a garage and just ask the first person you see for complex car repair advice.
No, of course not. You'd find the master mechanics. You have to act like a movie director. Set the scene.
Don't ask a random stranger.
Tell the AI who to simulate. You are now a master mechanic with 20 years of experience who only works on vintage European sports cars.
So connecting this to the bigger picture, what happens if we don't set that precise stage?
Well, the model just pulls from that average data. You get an output that's generalized, average, and probably useless for what you actually need.
And that leads perfectly into our first technique, which is persona adoption.
Right. Most people kind of do this, but they do it wrong. They're just too vague.
We need deep specificity, right? If you just say you are a coder, the AI has no idea what that means.
Is it a web developer? A machine learning expert?
Exactly. That lack of semantic density is fatal to getting good output.
Instead, you have to be really specific. Say, you are a senior data engineer with 10 years of experience in Python, specializing in cloud infrastructure and security.
That level of detail, it changes everything. The AI's vocabulary, its logic structure, it's forced to access deeper, more relevant parts of its knowledge.
Just think about the difference. A bad prompt is, write a blog post about coffee. It's generic, it's boring.
A good prompt is, act as a world-class barista running a cafe in southern Italy. Write 300 words on the art of making espresso. Focus on the aroma, the ritual, the crema.
So does that specificity just pull specific words, or is it deeper than that?
It's much deeper. The AI accesses specific parts of its training data related to that expert character and their logic.
Okay, let's talk about the single biggest problem with these models.
Hallucinations. Factual errors.
Yes. So we have to talk about the chain of verification, or CoVe. This is a technique from Google researchers.
What's so cool about this is that CoVe forces the AI to check its own work before it shows the result to you.
It's like an internal quality control system you build right into the prompt.
Yeah, it's a 4-step process, all in one prompt. First, it generates an initial answer.
Then second, it generates a list of questions to test if that answer is actually true.
Third, it answers its own questions. It's literally fact-checking itself. And then finally, it fixes the original answer based on that check. It's brilliant.
So if you ask it to explain the fall of the Roman Empire, it might ask itself, did I get the dates for Diocletian's reforms right? Or did I correctly attribute the Visigoths' invasion?
So how does this actually save the user time versus just doing manual checks?
It ensures accuracy and detail from the start, fixing potential errors internally before you even see them. It's about trust.
Next up, Anthropic found something really counterintuitive. Sometimes showing the AI what not to do is just as powerful as showing it what to do.
This is called Few-Shot with negative examples. We all know Few-Shot, right? You give it a good example of what you want.
But if you pair that good example with a bad one, and this is the key, you explain why it's bad, the AI learns its boundaries way faster.
I still wrestle with prompt drift myself, especially when the AI starts sounding too robotic or like overly excited.
Yeah, it gets all the exclamation points out.
It's like it loses its personality after a while. This technique is the best way to fix that.
You're giving it red flags.
So look at this template. Good example. 5 insightful ways to save money today.
Bad example. Save money now. Urgent. And then you explain why it's bad. Uses all caps. Sounds like spam. Lacks authority.
So what's the biggest benefit for someone who just hates that robotic or, over-the-top tone?
Providing those bad examples really helps the AI learn boundaries and avoid that robotic or overly excited style.
Okay, our next set of techniques is all about forcing the AI to slow down.
If you rush the model, it takes shortcuts. It guesses.
We want complex, layered thinking.
OpenAI uses something called the Structured Thinking Protocol for this. You force the model to think in assigned layers instead of just jumping to an answer.
You have to segment its thought process. So, layer 1, understand the goal. Layer 2, analyze the variables.
Layer 3, strategize the approach. And only then, layer 4, execute the final output.
You'd use this for really difficult decisions, like should you buy or rent a house?
Exactly. And the fifth technique, from Google DeepMind, tackles overconfidence. The AI always sounds 100% sure of itself.
Even when it's just wrong.
That's where confidence-weighted prompting comes in. You can ask the AI to rate its own confidence from 0 to 100%.
And here's the trick. You tell it that if its confidence is less than, say, 80%, it has to provide an alternative answer or state its assumptions.
This is a total game changer for unreliable questions, like, what were the average temperatures in London in the year 1650?
It'll give an answer, but maybe say confidence, 65% based on limited historical records.
So what's the core danger of the AI always sounding so certain?
The user might rely on a low-confidence answer without understanding the uncertainty or the assumptions the model made. Welcome back to the deep dive. We're moving from foundational control to maximizing relevance and quality.
So advanced prompt engineering is all about control. This next technique from Anthropic, context injection with boundaries, is like setting up a digital knowledge fence.
This is so important if you're dealing with specific information. You paste in your text, a user manual, a resume, whatever, and you tell the AI, only use information from the context below. If the answer isn't there, say insufficient information.
It guarantees the AI stays on topic. It prevents it from pulling in, random stuff from the internet that might contradict your source.
Absolutely crucial for customer support, where a wrong guess could be a disaster.
And then there's iterative refinement. No human gets it perfect on the first draft.
And neither does the AI.
So OpenAI uses this loop where you build an editor right into the prompt. You ask it to write a draft, then immediately critique itself, and then rewrite it based on that critique.
Whoa, imagine scaling that to 1 billion queries. Having an editor built right into every single draft.
The quality jump from iteration 1 to iteration 3 is just huge.
So what is the key outcome difference between iteration 1 and iteration 3?
After that self-critique loop, the writing becomes dramatically sharper and honestly more human-sounding.
For technique 8, Google Brain researchers found we have to flip the rules. It's called constraint-first prompting.
Right. Historically, we put the rules at the end. We say, summarize this article, make it funny in under 500 words.
But by the time the AI gets to the constraints, it's already started planning the answer.
The plan is already in motion. You have to flip it. List your hard constraints first. Must be under 200 words. Must not use the word delve.
Then you list your soft preferences, like use a funny tone.
Why is it so much better to put the constraints at the very start of the prompt?
Because when the AI knows the rules first, it plans the entire output to fit those precise rules right from the beginning.
Okay, technique 9. Multi-perspective prompting is inspired by Anthropic's work on reducing bias.
Instead of asking for one answer, you ask for 3 different perspectives on a topic.
This forces the model to explore the full semantic space, which gives you a smarter, fairer, more balanced answer.
So instead of analyze remote work, you'd ask it to analyze it from 3 angles.
Perspective 1, the employee focus on happiness and costs. Perspective 2, the boss focus on productivity and culture.
And perspective 3, the environment focus on carbon footprint, and only then do you ask it to synthesize a recommendation.
It's like adversarial planning. It's brilliant.
And finally, technique 10, meta-prompting.
This is the nuclear option.
Yeah.
This is what the red teams at OpenAI use when they need the absolute best output for a really complex task.
It's genius because it solves the main problem we have as users. We often don't know how to ask for what we want.
But the AI knows what input it needs to give the best result. So with meta-prompting, you ask the AI to write the perfect prompt for you.
The template is clean. You state your goal, like, I need to accomplish X. Then you tell the AI, analyze my goal, write the single perfect prompt to achieve it. Then execute that perfect prompt you just wrote.
I use this for a complex legal disclaimer. I am not a lawyer. The prompt the AI wrote for itself was 10 times better than anything I could have come up with.
So is this basically like hiring a free prompt engineer that knows exactly how the LLM works?
Absolutely. It leverages the AI's knowledge of its own internal systems to create the optimal input.
So what does this all mean? The big takeaway is simple. Stop asking simple questions.
Start building simulators.
If you're going to change just a few things, stop using those generic you questions.
Start assigning highly specific personas. And use chain of verification for anything that involves facts.
The gap between a beginner and an expert here isn't genius. It's just knowing how to talk to the machine.
You now have the manual. So go try one of these. I'd say start with constraint-first prompting on your next email. You will see an immediate jump in quality.
And consider this as you start building your simulators. If the AI performs better when simulating a single 20-year expert.
What happens if you force it to simulate a committee of experts who are intentionally designed to argue with each other before they reach a consensus?